guys, to my YouTube channel. Today we'll be dealing with direct strain application. Remember, we have direct stress, direct what. Now we'll deal with direct strain, not direct stress. So let's check the direct strain. Strain is given by, you see that E is different from, do not, the big capital letter like this E. This is Young modulus of elasticity. Do not write it like this, write it like that. Do not confuse the two, right? This one has no SI units, which is equal to X represent the change in length, L is a original length. This is measured in meter, and meter will cancel. This thing simply, it is a ratio, it has no SI units. It is a ratio of length, so it has no SI units. So as you can see, has no SI units. X is the change in length, L is the original length. Okay, let's check that. We've given example 1.4. Let's practice that. It says a concrete is 600 millimeter long and measures 200-meter long each side. Right. The Coulomb support, the load is that 90 ton on each square surface. So this is a square. You know the area of a square. This is simply just a square. So okay, no problem. Then says there, calculate the compression stress in the Coulomb. Ignore the mass and the Coulomb itself. Ignore the mass and the Coulomb itself. Okay, calculate the compression. Ignore the mass of the Coulomb itself. Okay, it's fine. Itself. Then that we want calculate the compressive stress. You know this is simply just a stress. It's a stress, that one, right? Whereby it's force over area. We will understand that, right? Okay, what is the force? The force here we've given 90 tons, but force is equal to mass multiplied by G. So we know that 1 ton is equal to 1000 kgs. You must know that. So this, you simply multiply this by 1000, convert it to kg. If you multiply that by 1000, if you have ton, multiply it by 1000. This represent 1000 actually. Multiply by 1000, multiply that by 1000. 90 multiplied by 1000 will be 000 00, right? But remember, this is kg. If we want the force, we'll multiply again by gravity 9.8 acceleration to gravity, then we divide this by the area, which is a square. Let's say measured 2 meter long along each side. It's a square, which is divided by 1000 there. This will be 0.2 multiplied by 0.2, the area of the square. If you punch this on your calculator, you'll get that the stress there will simply equals to what? 22,0725 megapascal. This is what the compressive that they wanted there. So yeah, we have B. If the concrete block becomes 0.5 short, which is compressive, calculate the magnitude of the strain. Now it's reducing in size, becomes short. It's become shorter. So it should calculate what the magnitude of the strain. The strain is like this. We know that the strain is X over L. Origin change in length. What is change? Become shorter by that. That means it's the change. It became shorter by that, but originally it was 0.6. Remember, divide that by 1000, you'll get 0.6. Then if you punch this, you'll get that your strain to be equals to 8 3 right, comma 3 times 10 to the minus 6. It has no SI units. Remember, the strain, it has no SI units, so that it is. We are done with that. So example 1.5, again there, a rod has a diameter of that of 30 and the length of that. The rod is hanging vertical, supporting a load of that hanging from it. It's fine. A says calculate the tensile stress in the steel. Tensile stress, we know that tensile stress is what? It's force over area. That is what we know. Or not shear stress. Tensile stress is force over area. We agree with that. So what about what is the force you've given there? 40 kilonewton times 10 just will be simply just 40 times 10 to the power of what? 3 divided by area. Remember, they say it has a diameter. That means this will be pi over 4 multiply into diameter, multiply by the diameter, which is 0.03. Then do not forget to square it. Remember, 30 millimeter divided by 1000. Then do not forget to square that, because the area of the is like this, right? So punch that, you get that your stress there, the tensile stress simply equals to 15.6,588 megapascal. So that is our stuff there, as you can see. So yeah, we are done with that. Is how you go about. Then B, calculate the strain of these rods if becomes that the strain if becomes that longer. This is simply what change, because becomes that means it's change. You cannot become if you don't change. You must remain there. So you cannot become blue while you are black. That means you have changed. That means it's the change. So we have that change there. So one the strain is that, isn't it, is x over original length. The change is that because the length is in what? It's in millimeter, and this is in millimeter. There's no problem. SI units they are matching. You can say 0.189 over that 700 as it is. If you punch this on your calculator, you'll get this to be equals to 270 times 10 to the minus 6. So this is what we'll have there. Yeah, so we're done with this. Now we have here activity 1.3 says you have given there a load, as you can see, a load acts on the or load of 40 kilonewton acts on the round steel bar that is long. That means it's a length there, and 18 millimeter in diameter. Given the diameter says there, the load causes the bar to become that. You cannot become. If you become, that means you've changed. That means it's the change in length to become that longer. So 1.1 says calculate the stress in the bar. The stress in the bar, whereby stress is force over area. The force is 40 kilonewtons. Then what about Mr. Area? What about the this is the steel bar, round steel bar, round. It has a diameter. We have a round steel bar with round steel bar. Okay, there's the focus. That means there's a cross section area of that will be pi over 4 times we want the diameters there. Diameter 0, 0, what? Divide 18 by that will be will be 0,018. Then you square this guy. Let's check there. 40 times 10 to the power of 3 divided by pi over 4 into 0,018 squared. This will simply equals to, if you have punched that, this will simply equals to 157,119 times 10 power 6, which is, I'll say, megapascal. Will be that megapascal. So yeah, 1 marks there, which is understandable. That is what you had. Then 1.2, the strain in the bar. The strain is simply equals to what? Change in length over original length. The change becomes, then also take it as it is, because millimeters, I want to show you the SI units are the same. You see, millimeter and millimeter will cancel, so this is nice. You can take it as they are. So we'll have 0,3, which is the change over original length. Yes, this will be, the strain would be equals to 1.5 times 10 to the minus 3. Has no SI units. Strain has no SI units. So this is what we'll have there. So 2, we have sorry about that. 2, we have a metal wire is 3 meter long, which is original length, has the diameter of 2 millimeter, a mass of 5 kg hanging from the wire, causing to become, cannot become. If you become, that means you have changed. Then this guys, that means that is the change. So 2.1 says the shear stress in the wire. Okay, shear stress simply force over area, whereby the force here will be 5 kg multiplied by 9,8. You know that force is equal to mass multiplied by g. So yeah, divide this by pi over 4 into diameter there, which is 2. You divide by 2 by 1000, you'll get that 2 will become 0,002. You square this 2 there. Then what I'm doing, then this, if you punch all of this, just punch it 5,5 times 9,81 divide by pi over 4 into 0,002 squared. Right, this guy there, you'll get this to be equals to 15, 613 megapascal. So this is what it is. 1 marks either way. Then here they want what? Shear strain. We know that the shear strain is a change in length over the original length. It cannot become, here is the change in length, becomes that longer. It's in millimeter, this is in meter, so you must change the SI units. It must be the same. 4 divided by 1000, 0.4 divided by 1000. Okay, there will have the change will be 0.00. Okay, 0.004. Original length, it was what, 3? Yeah, 3 long. So yeah, punch that. Simply equals to 133 comma 333 times 10 to the minus 6. It has no SI units. It's just a ratio. So yeah, this is how you go about, guys. Thank you for watching. Please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video.